54. Two curves C1 and C2 are defined for values of x and have respective equations. y1 is equals to 8x and y2 is equals to 2 times 3 to power x. That was 8 to power x, of course. So that the x coordinate of the point of intersection of the two curves is given by 1 over 3 minus log 3 to base 2. So at the point of intersection, the two curves are equal, isn't it? So it means at the point of intersection, y1 is equals to y2, isn't it? Where? At the point of intersection. So at the point of intersection, the two curves must be equal. So y1 is equals to y2 at the point of intersection, meaning 8 raised to power x is equals to y2, which is 2 times 3 raised to power. Are we together? So if you look at this kind of equation, first of all, you can simplify it into the simplest form, isn't it? You collect the terms with x on one side, isn't it? The terms with x on one. So if you look at 8 and 3x coming on this side, you divide both sides by 3x, isn't it? So that you end up with lots of indices when you have a squared over b squared. See, that's just a over b squared. See, that's the law of indices. So it means if you have 8 raised to power x over 3 raised to power x, see, that is just 8 over 3 raised to power x. Same power, isn't it? To be equals to 2, isn't it? Are we together? To be equals to 2. And you know very well in simplest form, 8 is the same as 2 raised to power, isn't it? Are we together? So, from here, if you introduce logarithms, what is the value of the index? The index is x, isn't it? Meaning the index is the logarithm of the corresponding number. So even if I leave this to be 8 over 3 before I factorize, index x is the logarithm of corresponding number, meaning x is log 2 to base what? Our base is 8 over. Have you seen that? The index x is the logarithm of 2 to base 8 over 3. Now from here, you can now see log 2 to base 8 can actually be written as log 2 over log 8 over 3, isn't it? Are you seeing that? Good. So once you've seen that in the numerator, we have log 2 over the denominator. When you take the log inside, division changes to subtraction. Have you seen that? If you take log 8 divided by 3, meaning if you take the log inside, this division changes to what? Subtraction, meaning it becomes log 8 minus log 3, isn't it? Log 8 minus log 3. Then look at this. What is 8? That is where you now factorize. 8 is 2 raised to power, isn't it? Yes. Then this power 3 can be written as the coefficient, isn't it? Yes. This power 3 becomes the coefficient, meaning that log 8, which is the same as 2 raised to power 3, is the same as 3 log 2. So log 8 we can write as 3 log 2, isn't it? Yes. Are we together? Yes. Now at that point, so you divide both the numerator and denominator by log 2 to remain with 1 in the numerator. Isn't it? Yes. So you must divide both the numerator and denominator by log 2 to remain with 1 in the numerator. So if you do that, what do you get? Divide both the numerator and denominator by log 2, meaning numerator is log 2 over log 2. The denominator, 3 log 2 divided by log 2 minus log 3 over log 2. Are we together there? Yes. Yes. So if you perform that kind of operation, what do you have? Look at the numerator. Log 2 divided by log 2, you get what? 1 over log 2 divided by 2, you remain with 3 minus log 3 over log 2. Then what do you have? This is 1 over 3 minus, what is log 3 over log 2? Log 3 to base 2. Are you seeing that? Yes. Yes. So if you see that you've reached the expression they are looking for, then you add there, isn't it? Yes. You transform it in a manner that you are able to get the expression they are looking for. Even if we've reached here, we've already found the value of x, isn't it? The x coordinate, isn't it? Even this is still absolute. But we are doing all this to write it in the form they are looking for, isn't it? Good. So that is how to handle that kind of problem.